Good morning, dear students. Welcome back to online classes. So, as we know all, dear students, in the last class we have been discussed about simulation about the 3D printings. Already we have been gone through the simulation of stereolithography process. Thereafter, we have been discussed the fuse deposition modeling process, right? In the last class, we have been discussed about the selective laser sintering process, but we couldn't execute the simulation operation because of the some technical issues. So today, our planning is to discuss the simulation about the selective laser sintering processes. Today, we need to take two experiments. We'll wind up this simulation class. Tomorrow, we will discuss the normal classes. Thereafter, again, we will take the another two simulation processes. On Monday classes we need to take once again simulation classes. Today, as I planned, simulation about the selective laser sintering and selective laser sintering process. In that we have two methods. One, we can able to choose the non-metallic materials as well metallic materials also. Let's see how the simulation is works about the selective laser sintering. Already I have told about the theory about the selective laser sintering process. I will not take much time to discuss about the theory things and procedures. Everything we have been discussed already. Directly we can go for the simulation of selective laser sintering process. In that we the case is non-metallic materials. The selection of the material is non-metallic material. Let's see the how this SLS process is works. Right now I will choose the selective laser sintering process for non-metallic materials. So here we have a theory. Already we have been gone through the theory, we have been discussed, and also the procedure also we have been discussed. Or else once again we will take the procedures so that we can understand better how this process will carried out step by step. Theory and other things I will not take again. So as we know all the procedure is a very simple steps which are involved in the procedure, or we can sometimes we can call it as a instructions. So once you click on the button of laser beam, definitely the laser beam will be displayed on the screen at the left side of the screen. So after that, once you can able to see that laser arrangements on the screen, then you can go for the feed system or feed piston. Once you click on the button feed piston, definitely the powder bed piston will be shown. Once this will be shown, we can able to see on the screen, then we can go for the powder feed systems. Once we click on the button powder feed system, that we can able to see the simulation how the powder will carries the pistons, that we can able to see with our naked eyes, this through the simulation acting. Then you can press the button of the leveling rulers. As already we have been discussed what exactly the main function of the what exactly the leveling rulers are does. And also we are we know also we have been gone through the in detail about the rolling system. uh, Once again we will discuss meanwhile we are looking into the simulations. So once all the arrangements are keeping ready, then we need to start the button. Once you press on the button start button, the process is begins, right? After the process is complete, definitely we know everybody just you can click on the button on the stop process. Once you click on the button stop process, definitely the process will be the start, then the produced 3D object we can able to see with the screen. So let's start with the simulation. So all right. Yes. Can you able to see this screen? Kalyan and others, can you able to see this process, this simulation process?
Yes, sir. SLS process.
SLS process. Okay, let's start with, yes, thank you. Let's start with the once again the principle of this SLS process. Already I have been told in the last class, SLS process means selective laser sintering process. the which portion we need to create, which portion means what we have in our mind, the desired shape and size, because this is the powder bed. That entire powder bed is built by the powder materials or powder materials, maybe sometimes the metallic materials or else non-metallic materials. Non-metallic material in the sense, already I have told that non-metallic materials means polymer, plastic materials or thermoset materials, may sometimes thermoplastic materials or else sometimes ceramics materials, right? These are the non-metallic materials. Here the today's process or the first process, now we need to simulate the SLS process by using these kinds of the non-metallic materials, may sometimes plastics, polymers. In polymers, in case of the polymers, may they are in the they are thermoplastics or thermoset materials, or sometimes there will be the ceramics powders, right? Also the principle is that only the selective laser, so in that entire bed we need to select our area. So the what is our desire shape, what is in our mind, what that customers are expecting, what the customer demand, as per their indentation, as per the 3D diagram, we need to create the 3D models in that powder bed. How this 3D is created? Layer by layer. Each and every layer is scanned by the laser. Only the selected portion will need to be scanned, hence that will be generate the 3D object, right? Let's start the process. Yes, according to the procedure or instructions, what they said, just you click on the brush button over the laser. Now I am just click on the laser. Yes, see, once the pop-up of the screen will be open at the left side here, that we can able to see here, right? Just now once you click on the button on the laser, see, this is what laser arrangements, as well as we can able to see the feed systems are beds. There are two beds at the bottom, right? So through this bed we can able to supply the raw materials, or this entire bed is completely filled by the raw material. Maybe sometimes it is a metallic or non-metallic material, that's depending upon our applications. We can able to choose the raw materials. This is we can call it as a bed, and here we can able to see the laser beam arrangements, especially here in this case which we are using the lasers or CO2 lasers, which we can successfully using. That laser beam is stresses the raw material. As the raw material is fused, then or fused, the fused and the atoms are combined each other, and that way the layer by layer also they combine each other. First the atoms are combined, hence that becomes a first layer. Thereafter the amount of material will come over the first layer. Again that powder is traced by the laser beam. Now the atoms also join together or combine each other due to the fused heat, as well that second layer is combined to the first layer. The way we can able to build our 3D product. See, now the first step, now we can able to see the two beds at the bottom and the two laser arrangements at the top. The next step is to press on the button on the feed system. Yes, now we can able to press the button of feed system. This is the second instructions. Now, yes, this is what feed pistons. Now you can able to see the feed systems or the feed pistons in the both the figures. Left side, whereas right side we have a two feed systems. Now the piston is ready for feeding the raw material, right? So whenever this piston is moves power, this will carry the amount of raw material to the platform, right? The definitely the piston will successively or it's flexibly mounted inside the what we can call it is bed. So that the particular size of the shape and size of the piston which we can use, this is flexibly mounted inside the bed. Now once the piston is moves up, that will carry the amount of raw material. Later what happens, just you can see the next. Now I am pressing the powder feed button. Yes, now the piston is, once the piston is moved towards or is start moving upward direction, that will carry the amounts of powder materials. This is we can call it as a powder supply or feed supply. So you can able to see in the both the figures, right? So whereas in the left side we have a two systems. Now the two systems are ready for the next process. So what we can able to see, this is the light orange, pink in color is there. This is, we can call it as a supply material or raw material. With the help of the piston, we can able to take this raw materials. This piston is pushes the raw materials to the platform, to the platform that can carry the raw materials. Now we can able to press the button in the next process. So just go ahead to the next. What it now, see, once this piston will pushes the raw material will yet come up, upon the platform. Once it will come upon the platform, here we have a leveling rollers, what we can call leveling rollers, or carrier rollers. These, the main function of this carrier roller, only one roller we can able to choose here. Sometimes it is a big process, you can take the two rollers, may that arrangements needs the 2 3 rollers. Now here only we can able to see the one roller. The function of this roller is to carry simultaneously. Once this piston is goes up, the amount of raw material will come upon the platform. Once it is come upon the platform, here we have a roller. The main function of the roller is to carry these raw material to carry it towards to here. This is, we can call it as a leveling. That why we can call it a leveling, because the roller will not blindly take the raw materials. This will not in the form of bulk. Only the required amount of raw material that will collect from this feeder or this bed, then that will be level over the, from carry from here to here, then here that the roller will be. So that make ensure the leveling of the raw material over the platform. Only that roller will make ensure what, how much amount of material we need, because we need to create a single one layer. That layer thickness will be already, it is determined, the how much layer thickness we want to take, that is the layer, how many layers we want, 100 layers you want, you can calculate the each layer 1 mm. So based on the quantity and based upon the height of the product, we can divide the number of layers. That also, these things and this principle and this phenomena already we have been discussed, that we need to divide the number of layers based upon the quantity and height of the sample. Right, now the one layer, we suppose we want a layer thickness will be the 1 mm or 2 mm or 3 mm, sometimes 5 mm. That much amount of only per 3 mm, how much amount of material we need, that much only that level this roller will carry and fed over the platform, and that will be making sure the leveling. Now once the level is one leveling mechanisms is over, now we need to take the, now the process or that material is ready for exposing to the laser beam. Now we need to process the laser, that's it only. The next process is that after the leveling mechanisms, now we need to press the button start. So because everything will be ready now, the raw material is also ready, a leveler mechanism is done, right? Everything is ready, and laser is also ready. Now you can able to see the how the process is uh, begins. So now you can able to see through this simulation process. Now the simulation process is starts once we done all the arrangements. So you can able to see, so how these pistons are moves down and moves up. So this is the mechanism we can supply, or we can push the raw materials up to the platform. So whenever this raw material come across over the platform, immediately the roller will be maintain the amount of required raw materials over the platform. Yes, now the roller mechanism. Once the mechanism is done, the laser will start scanning. See, we can assume it is the first layer is over now. Now again the raw material will coming. Yes, it's come back. Now laser is scanning, hence it becomes second layer is ready. Now the third layer, how it is, right. Now again roller will carry carry the raw materials, right. Now the laser is scanning. Now the third layer is ready. Again roller is carrying the raw materials. Now that does the leveling mechanism. Now again it is ready for exposing to the laser beam. The laser is scanning the material. Like the fourth layer is ready now. And also you can able to see the level of the piston or platform. This is, we can call it the platform. Now the platform is slowly goes down. How it goes down does mean that number of layers are built over the platform. Yes. See, this will goes down till the 3D product, completed 3D product is will form. Up to that, this platform will goes down and goes down and goes down. How it goes down? The layer by layer, how that material is deposited over the platform is goes down. This process is keep on going till the 3D product will finish. Any questions? Is it visible properly or not?
Visible, sir.
Visible, na? Is it clear or not?
Yes, sir.
It's clear now how this selective lasering. See, the why we can call it as a selective lasering system, because our material is just, you only can look at the figure from here to here we have a raw materials. Say yes or no, right now? You all you can able to see this, and you can look at the figure, the where the raw material from here to here we have, from this end to the this end in the throat. That's what we can call, this is the uh, bath, or else it is a bed. So here we have from here to here we have a raw materials, but a laser is only to traces the this portion only. Can you able to see this? Huh? This never ever the crosses the limit, right? Only this portion that scanning laser is only to scan, only to traces the required area. Only the cross section of this only that will traces is the only this portion is to expose to the laser beam. This laser will not cross their limit. This will not come out of this range. And from this side and this side, only this portion that will be crosses, because we make ensure that arrangements, because only the required, this is what selected portion, this is our selected portion, only this portion we need to build the raw material. We don't want here and here, because this is our required shape and size we want. Hence we are adjusting the laser beam that should not cross their limit. Only within that limit that laser will be scans. Hence once it scans, that materials are fused. Means already I told you that what is the mechanism of fuse. Means here we are maintaining the temperature through the laser beam. We can maintaining the temperature that just below the melting point of the raw material, right? At that temperature, what happens? At that temperature, the materials are turned into the plastic state. At that plastic state, each and every atoms are come in contact. There will be the pack closing between the 2, 3, 4, 5, 6 up to 15 atoms combined together to form one thin layer, right? This is, we can call it as a plastic state of bonding. That one advantage of this laser sintering system, we can able to we can able to achieve the plastic state of bonding between the particles. This plastic state of bonding is much harder, stronger than the other fusing techniques. And also one more drawback is there. Yesterday only we discussed. Sometimes this temperature that will generated from the laser now, if suppose the temperature will be more than the melting point, suppose that will crosses the critical temperature of that particular material, that may causes the defects present in the sintered powder, right? That may causes the some defects present in the defects, means from the over temperature and overheating. Due to that overheating, there will be the pinholes, cracked ears, right? Blowholes, contraction or expansion, such kinds of the metallurgical damages or metallurgical issues maybe chances arise in the 3D product due to the uneven temperature or overheating. That also one of the drawback, right? I hope you understand about this process. Only the selected portion we can able to traces and scan it, and we can generate the 3D product. Any doubts? It's clear or not? Dear, it's clear? Say yes or no at least. Kalyan, are you there?
Yes, sir.
Yes. It's clear, Aura?
Yes, sir.
Ah,
Sir.
right.
Clear,
Okay.
sir.
Yes, thank you. Now, once we just stop the button, or means you can press on the stop process, now you can able to see. This is see. This is the total schematic arrangements, or you can call it a schematic arrangements, or this is the process how it begins. We can able to see with this image. See, so these are the rollers, and this is the uh, here we can. This is the platform, and this is the we can call it as a so bed. So here there are two types of the beds, and because we are simultaneously we are running the two process, so that you can understand better. So and this is the power mechanism with the help of the movement, so help of the movement of the piston inside the um, bed. So here we can able to see the raw material, and here there will be the scanning, uh, laser scanning is there. Only this portion we need to scan with the help of the laser. Hence this is what we can say, this is the sintered part, or this is the 3D product, right? This is what we are expecting the shape and size of the 3D product. Now we are successfully uh, producing the expected 3D components with the help of this SLS process. But these 3D product is now made by the non-metallic material, right? Because this process beginning only I told the aim of this process is to produce the non-metallic 3D components, right? Whatever this we can able to see, this product is now generated by the using the non-metallic materials such as plastics and ceramics materials. Okay, now I will move on to the next process, right? Metallic materials. Just look into the simulation of both the process, then we can understand whether we can able to take the same parameters, or any variations or any changes we need to take whenever we can use the metallic materials. Let's see whether it is the same, or else we can take any other parameters, right? Now I will back to the process. So tests later at the end we will take the tests or all these things. Now we can able to see how this process works. That's very important. Yes, now I will take the metallic process. The means there's a simulation of selective laser sintering process by using the metallic materials. Let's see, directly move on to the simulation process. Yes. Selective laser sintering process by using the metallic materials. Now let's start the process simulation. Yes, same. Nothing will be changed here, right? So again, there will be the bed at the both the side, and laser arrangements. Let's press the next step. So you can able to see the next step. Again, there will be the piston that will be seated into the bed. This is properly seated into the bed that we can able to see. Let's move on to the next step. Metal powder. Yes. Okay. Yes. Now, so here we can able to see the so metal powder it is. Now earlier it was non-metallic. Now it is a metallic powder. Once we can click on to the metal powder as well. So reactor on. Now this is the piston is rising the raw materials now towards to the platform. So here we can able to see the raw materials which is in the form of metallic powder. Let's move on to the process start. Yes, kindly mute your mic. 48. Hello, mute your mic. 48.
70 48, mute your mic, man.
Yes, no problem. I have muted him. See, so now once we start the button, nothing will be changed here. So instead of the roller, now we are using the so recorder arm, right? The only thing is the change is the instead of a roller, now we are using the so recorder arm. Anybody can guesses the why we why the this simulation, this simulation is changing the or replacing the roller to the arm. Mahendra, Kalyan.
Hello, sir.
So here we are changing the roller from the react recorder arm. Why? Only that thing only here is the change. The everything will be the same principle. Now we can able to take. There is no much difference between the non-metallic and metallic material. Non-metallic sintering process and metallic sintering process, both are the same principle. They are both the machines and both the concept or work in the same principle or the single principle, but only single changes arrangements wise. So only one thing is now here we are changing the instead of roller, now we are using the so recorder arm. Can you able to see this? The recorder arm is moving now. This recorder, what is the function of the roller? Earlier was we have a roller that the function of the roller is to level the outer form of the plastic materials, right? Now the instead of that roller, now we are using the reactor recorder arm. That recorder, why we are using the recorder arm? Hmm? Do you have an answer about this? No, na? Okay, let it be, no problem. So here we are using the this is the blade type of the so leveler instead of circular type of the leveler. Here this will look like an seat or blade type of so recorder arm is there instead of roller. Because why we are using the roller? Because that is a plastic material. So we need to compress that plastic materials, because that is sometimes it is a non-dense particles, but the polymers are non-dense particles. So however we need to compress them, then only we can able to carry easily. That is the thing we are using the roller itself. It's not only to carry the raw material, that will dense the powders, then that will carry to up to the platform. So that's the reason we are using the rollers in that non-metallic materials. But here the metallic materials are already, these are the denser particles. However, we need to we don't need a roller mechanisms here. Just we can take the just like in the blade or seat type of the arm, just that will carry the raw materials. Then that raw material is spread over the or spread upon the platform. Then that exposed to the laser beam. That laser will be scans the required cross section of the raw material only. That's it. That will be fused, and that metallurgical combination is takes place between the each atoms as well as between the each layer. Hence, our the build will be platform like way. Right, that everything will be the same, nothing will be a change. Whenever we can able to take, whenever we can take the materials metallic and non-metallic, you can able to take any kinds of the material, but process will be the same. The only thing is to change here the leveling of the raw material. In case of non-metallic material, that in that cases we can able to take the rollers mechanisms for level the raw materials, because of the plastic materials are non-dense materials. So hence we need to we need to make ensure that particle should be dense. That is the reason we can able to take the roller mechanisms. But in metallic cases, already the metallic materials are high density powders. Since there is no need to take the rolling mechanisms. Simple that arm or simple plate or blade, doctor blade like blade, we need to take the raw materials to carry the raw materials. Later the raw materials are fed over the so platform. The remaining rest of the portion and rest of the principle and rest of the working things activities are same, uh, right? Now Hope you understand. It's clear. Now we'll stop the process. Yes, again it is now. Yes, now 1 second. Only keep it in your mind. Only the difference between whenever we selective lasering sintering is this, mechanism of the selective laser sintering for different materials. Metallic and non-metallic will be the same. That we now we understand. That we have been understand now once we complete this process. That's what our aim is to. Let's check whether the process will be changed or not whenever we can take the different kinds of the material in this process. Nothing will be changed, only the thing you change. Keep it in your mind. Suppose anybody can ask you in the examinations or any, so in you come across in the future, anybody can ask you these questions. The how your arrangements will be takes place whenever we can change the raw materials. If the thing will be changed, sir, working principle of the both the process will be the same for metallic and non-metallic materials. Whenever we consider the selective laser sintering process, both the materials we can able to choose, sir. There will be nothing, there will be not a much difference between the both the process. Only the difference is that, so whenever we are taking the non-metallic materials, we need to take the for leveling purpose, we need to take the rollers in the non-metallic materials. Suppose if it is on the metallic material, if you are taking for the selective laser sintering process, just you make ensure that simple blade type of levelers or a C type of levelers is enough to level the raw materials, right? Only these things will be the different. The rest of the things will be same, right? Now we'll move on to the post test of this process. Later we will discuss the one more process because we have a much time today. One of the Bankar sir is not there, so up to 11:45 we can take one more process. We will take because as I told you that tomorrow onwards we will come back to the normal classes, right? So we need to take one more process. Before that we go for that post test. Let's check ourselves how we can capable to answer these questions. I can call it as an self-evaluation. The simulation of selective laser sintering process for metallic materials. Let's answer these questions. Which of the following additive manufacturing techniques is an example of powder bed fusion? See, I will repeat once again. Which of the following additive manufacturing technique is an example of powder bed fusion? The answer A, SLA, stereolithography. So drop on demand, so DOD process, or SLS process, FDM process. Which one? Which one process you can able to take? Just guess as the examples. Can you hear me? Hello?
Yes, sir.
Just you can guess as the answer. At least you don't know, you can guess. Eventually we will get the correct answers. Which of the following is example for the powder bed fusion? SLF,
SLS, sir.
SLA.
Yes,
Any other answers? Are you there? Really?
LS, SLS, sir.
SLS.
SLS.
Laser center.
Okay, we will pick on to the SLS process. Let's see the answer at the end. Now, second, so listen carefully. So, which of the following is not a characteristics of SLS process? Once again, I will repeat. Which of the following is not a characteristics of SLS process? Printed parts have a porous surface. Second answer, the residual stresses are not generated. And C is the powder materials is fully melted and solidified. And the last one is expansion setup. Tell me, which of the following is not a characteristics of SLS process? Come on.
Sir, second one, sir.
Second one is the residual stresses are not generated. Okay. Any other answers from you? What about others? Are you there?
First one, sir. First one.
First one,
First one,
printed
sir.
parts have a
Parts have
porous surface.
porous surface.
Okay, first one. Powder material is fully melted and solidified. This is the characteristics of the SLS process. Okay. Hmm? So keep it in your mind your answers that someone is telling that printed parts have a porous surface. One thing. Second one is the residual stresses, and my guesses is the C. Let's see what happens. Which answer will correct? At the end we will look into the answers. Just I am fixed on to the C. Powder material is fully melted and solidified, because here you can able to see not a characteristic of this SLS process. This is also my guesses. Let's see what happens. Now coming to the third, SLS is a particularly useful for industries involving SLS means selective laser sintering process is particularly useful for industries involving mass production, rapid prototyping, economically cheap production, or high quality and limited production. Which one of the following is suitable for the SLS process? Which is
Rapid
suitable?
prototyping, sir. B.
Okay, okay, rated. Any other answers? All of you agree with this answer?
Yes, sir. Rapid pro.
Okay, let's fix to the rapid prototyping. Now coming to the fourth question is, which difficulties are caused by thermal distortion in the SLS process? Which difficulties are caused by the thermal distortion? This is the kind of the defect, thermal distortion in the SLS process. Greenery surface finish, handling issues, shrinkage and warping, none of the above. So yesterday only we have been discussed about this, the limitations of SLS process. Also, just before 10 minutes we have been discussed while we are discussing the simulation. Just I told you that there will be the advantage and drawback. We just only we will discuss. We have been discussed. Yes, let's guess the answers. So which one is correct following the answers? Greenery surface. Greenery surface finish, handling issues, or shrinkage or warping due to the high temperature present in the SLS process. That may causes what? I told you that some distortion or some defects may arise if your laser
Grainy
temperature.
surface finish.
Grainy surface finish. Okay. Any other answers? Any other answers from you? All of you agree with this answer?
Sir, C, sir.
Exactly. See, okay. My guess also. See, let's see what happens. Shrinking and warping are caused by the right. Which of the following laser is used in SLS process? Am I audible, Mahendra, Kalyan, and others?
Yes, sir. Yes, sir.
Yes, yes. The which of the
Sir.
following laser? Yes, which of the following laser is used in SLS process? Laser, CO2 laser, CO2 ND ag laser, or YB fiber laser, CO2 laser, or ND ag fiber, YB fiber laser. Which laser we can able to choose for the selective laser sintering process? Just only we have been discussed. Which laser? At least
Sir, first one, sir, NDR CO2.
NDOG CO2 or CO2 NDOG.
Or last
YB
one,
pipe.
sir.
Last one. Last one is not possible. Okay, first one is someone is telling. Now I will fix on to the second one. Let's see what happens. Now we will submit this quiz. 3 out of 5. This is wrong. And this second option of the fifth question is wrong. And in the third question, rapid prototyping answer is also wrong. Let's see the right answers. So once I will change my option from B to A. Again it is wrong, and B to A to C now I'm changing is right. The answer C is right for the fifth question. Now we'll look into the question 3. In question 3 now I will change from B to A. Yes, now I will take A, submit the speech. Now A is also wrong and B is also wrong. Now we will look into the C. Is also wrong. D we can take it. No, C, just submit the quiz. Wrong. C, D we can take and submit the quiz. Yes, D is a right. High quality and limited production is the correct answer for the third question. As we can see, the third question is SLS is particularly useful for the industry involving high quality and limited production. Right? However, now we will get the correct answers for this particular process. I hope you get an idea about the simulations as well as the theoretical part of this process also. I think it's clear. Now we will move on to the one more simulation process so that we can yes. Now we'll move on to the next simulation method. Just kindly mute your mic. Yes, here we can able to see the next one is in selective laser sintering, metallic and non-metallic we have been discussed. Now the ninth one is the simulation of ice laminated object manufacturing process. Am I audible?
Yes, sir.
Right. See the aim of this laminated object
Sir,
manufacturing
third
process.
question continue ಮಾಡ್ತೀರಾ sir?
Yeah. I told you now the Bankar sir is out of station, so instead of Bankar sir class also we will take the Moir sir is already he has been taken the 1.5 hours. Now the rest of the 1.5 hour I will engage till this class will be 11:45. Right? Is clear?
Okay, sir. Okay, sir.
Yeah. And the 20 minutes we will clear so that we can finish up the one more simulation process. So this will be help for our normal classes. We can tomorrow onwards we will engage the normal classes, right? The coming to the simulation of laminated object manufacturing process. Already we have been gone through this process also. This is the one of the 3D technology. This also we can select for industrial applications. This is the here we can able to produce the seat structures 3D products, right? Through this mostly this process generally we can call this process is LOM process in 3D technology. Generally the people are used to call it is LOM process in 3D technology, means laminated object manufacturing. Through this process we can able to produce the structured parts, thin sheets and some other structural industrial structure and domestic structures components we can able to produce through this process. Let's see how this process works. By the simulation we can able to understand that here we can able to see the image of this process. Just I will let me to clear this. Here we have an image sorry mirror, and here also we are using the laser beam. These are the heated rollers. There are two heated rollers we need to So fuse the particles or fuse the thin sheets, but here we are using the, instead of powder materials, here we are using the thin metallic materials. We can able to use this in this process. Here we have a materials in the form of the thin sheets. This is the supply roll. Through the supply roll we can able to take the thin foil structure of the sheet metals. Hence the sheet metals will spread over the platform. Here this is actually we can able to see this is the created 3D part over the platform as per the desired shape and as per the desired 3D CAD models. Here we are so removing the materials by the using the lasers. Now we need to create through the in sheet only, we need to create the required shape and size. Right, you can able to see this is the created 3D product from the sheet structure, right, with the help of the lasers. And this is the layer counter, what I am saying, showing you this is the layer counter, and this is the back portion. Once this 3D product is created from the raw material, like this C type of raw material which we can use to create this type of the 3D object. Hence once this 3D object is created, later they are coming to the another file. This is what we can call as a take up file. The printed 3D object is file into the take up row. This is the supply load, this is the take up node, this is the platform. So here you can able to see this is the layer by layer. Sometimes we need to create the big structures, then this layer, this what we are creating this 3D image is, this is around about particularly the thin file it is, maybe sometimes it is less than 1 mm thickness it is. Now we need to create the big structures around about the 100 mm and 500 mm thickness plates we need to create, or 20 mm or 50 mm thin sheets we need to create. At that sense, this number of layers are combined together to form this big thickness 3D product. This is the platform. Once this platform is moves down, the layer by layer, these kinds of the 3D layers are built over the platform by combining the number of layers till that the required thickness and required thickness of the 3D generate will be generated. Till that this platform will moves down and number of layers will be deposited one by one. Okay, so now we will go on to the simulation process directly. So theory, however, we are discussing already. I will not much time about the theories. Same theory here we can also expect, and already we have been discussed this figure. So now I will highlight some advantages so that we can able to understand, because definitely in the final examination, in the video examinations, definitely you need to write the advantages and limitations of the particular process. Maybe the 6 and 8 marks they can ask you draw the neat figure of the LOM process, laser laminated objective process, or LOM object manufacturing process. You need to draw the neat figure and you need to describe the figures, and also you need to write the working principle of the particular process. Thereafter you need to write their advantages and applications as well as the limitations. Then only you can get the full marks. Definitely you can go through the previous question papers. Definitely they are asking you the advantages and limitations of the each 3D techniques along with their applications. Sometimes they can ask you to discuss the applications also. For that reason, we need to discuss the some advantages of this particular process. Relatively high speed process. Yes, definitely the LOM process is relatively high speed process and low cost, readily available materials, because thin foils and ready materials which you can use here. No need to take the machining and no need to take the production of the raw material. The thin sheets are already available. You can take the readily available materials for this particular process. And the third advantage of this process is large scale build possible. Yes, that's what I told you. So this process is only suitable for to construct the structure type of the products. So hence it is a large scale build possible. No chemical reaction, so not health threatening. 100%. Here we are we are not taking any kinds of the raw material which are in the form of the powders. So sometimes in the powder form we are taking some ceramics and plastic materials. Some kinds of the plastic and ceramics having the hazardous issues. Yeah? So hence that threatening to the so human health, that will be affected to the human health. So that is the reason is that will also possible in there some of the 3D printings, and few 3D printings are we are using some dangerous chemicals particles. But in this situation, or but in this case, in this LOM process, no such there is no chance of creating the chemical reactions and hazarding things. Hence there is no threatening for the health. The parts can be used immediately after the process. No need for the post curing. Curing is not required this process. Once the one part you created, that process ready for the immediately it's ready for the next process. Hence this the very short in time. So no additional support structure is required. That is also right, because that everything will be so self-supported arrangement. It is, we can call it as a self-supported arrangement. Everything will be already ready. There is no need to take the separate support structure systems to hold the machines or products. Such kinds of the activities doesn't need for this process. Hence these are the strength of this. These becomes the strength of this particular process. Suppose if you look into their limitations, sir, we know we want some limitations also because of selection regarding. So here we have some limitations of this process. Removal of the scrap material is laborious work or laborious task. Because of this is the big arrangements it is, because here we need to take the number of parts, assembled parts are more in this particular machine, because you need to create the big structures, right? So at that reason here we need to construct a big machine. So however it is a big machine, it has a number of n number of dismelting parts. Once the work is done, we need to dismelt all the arrangements. It will take the big task. This will be the big task, and this is the laborious task, right? That is one disadvantage. That one more, the JED resolution is not high as per the other technology. Comparing to the other technology, the so resolutions of the uh, 3D printing products will be the so less. The materials like paper can be so fire hazardous. Some materials like papers, because we need to sometimes we need to create the very thin foils, means they are look like in paper in size, paper in shape and size, just like a paper. These materials may sometimes create the so fire hazardous, may sometimes because of the temperature, so these papers may be get melted, or maybe the fire will be the generated, there will be chances is there. So this will be becomes one of the hazardous. Need for the sealing step to keep the moisture out. Okay, this process needs some sealing requirements, because keeping the moisture out, because moisture we need to keep the moisture, so that's it. We need to seal the products. The paper objects have a lower surface finish, the accuracy and stability as compared to the other AM methods. So this will be the lower surface. Because of the paper, definitely you would have observed and you would have experienced about the papers. The papers are very uh, accuracy and the stability of the paper is too much weak. So such kinds of the products may we can produce through this LOM process. So that's the things that one of the disadvantages. The paper type and other thin file structure materials are doesn't possessing the high stability and accuracy. Also surface finish is not good. This is the limitation, one of the limitation of this process. In applications, once we can look into the application of this LOM process, where exactly we can take these processes, what kind of the products and what kind of the components we need to or we can able to produce through this LAM process. Here we can able to see that some investment casting patterns. For traditional castings methods, they need these some patterns. Now that patterns we can able to produce through this 3D technology. So this is the pattern is one of the important tool to get the required shape and size into the sand materials. Hence we can use the pattern. Pattern is a replica of what we are going to producing. Hence these patterns from the for castings, these patterns are now we can able to produce through the 3D technology. Especially for this LOM process, we can able to produce the patterns, and also the concept verifications. So here we need to take the concept verification, because sometimes this system has some uh, feedback systems, so that through that feedback systems we can also use the concept verifications, and also we can anytime and anywhere we can change the concept and we can take the, hence this becomes the wide range of applications, right? And uh, pit check. So these are the some other industrial applications we can able to produce the some pit checks like this devices. These devices for the industrial application we can use these parts. These are such kinds of applications also we can able to produce. And decorative articles, some decorative articles, because for example tablewares. I hope you might have observed some tablewares, some sanitary wares, some attractive floor seats, tableware, chairwares, floorware means floor. We are using the some covers for the walls, and also some covers for the floor covers. All these things are the attractive articles we can able to produce through this LOM process, because all these are the structure parts we can able to produce, right? Now directly I will go for the simulation process of this LOM process, how this LOM process works. So before that procedure we need to check. As usually the procedure is the same way. To click on the platform, the movable platform will be appear on the screen. So after the once you can able to see the platform over the screen, then you can click on the material indication of the material. You can click on over the material indication. Once you press the button, the material supply role and material sheet and wash take up role will be shown in the figure. And also up to that you can able to click on the heater rollers, then that roller are displayed on the screen, then they start heating the raw materials. And just after this we can able to click the laser. Once you press on the button on the laser beam or mirrors and optical head will be displayed on the screen. After all the arrangements are once done, then you can start the process by pressing the button, start button. The process will be begins. Once the process is completed, then you can stop the button, stop process, right? Let's start the simulation. Yes, so here we can able to see the one by one steps. Now as per the guidance of the procedure and instructions, now I am press on the button to the platform. See here we can able to see. Once we are press on the button on the platform, now the platform we can able to see on the screen. This is about the platform. Yes, you can hear this is the platform. This is the structure part, not this is the support part. This will be the made up of the high rigid materials, and this is the rigid part. This will give the support to the platform. That's it. Next we need to click on the material. Yes, once we click on the material, see you can look into the step by step how this LOM process is arranged. You can look into the each and every steps, how this arrangement is takes place. Once we click on the material, now over that platform the material is ready. Here we can able to see the take up drum. Here we this take up drum, here we got the thin layer sheet. It is here there is the spool or bundle of thin file structure sheets are wound over the spool. Here the raw materials are available. This is the revolving feed. So here we can take the raw materials, the required amount of raw materials, we can pull it and we can so cut over the seat. This is the platform. Now we can this you can see this is the seat. Yes, once this raw material we need to make ensure that raw material should be fall on the substrate or platform. We make ensure that by using some different mechanisms this sheet should fall on the platform, because this portion only to expose to the laser beam, so we need make sure that raw thin sheet should be fall on the platform. Once it fall on the platform, this portion is exposed to the laser beam. At the top we can take the laser action or laser scanning laser. Once this laser is exposed, let's I will see the now before that heating roller or heated rollers. the rollers are now here. We can able, because this is the solid seat. So however, we need to fuse this seat, because seat now it is in the room temperature. The why we are taking the seat means because once it turn into the plastic state, we need to fuse that. So fusing temperature, we are required to amount of temperature we need to supply from the heating rollers. That roller will be once it fuse, and this will squeezes the materials. Now this will be the material will be fused, and there will be some contaminations are also present in the seats, so they may burn out when we are seating. And also this roller will be the properly roll the seats over the platform, because sometimes there will be the gap between the platform and the raw materials. And once we are using this roller, once it roll over the work material is now it will be the stretch. It will be straight and it will be the stretch, and hence this we can able to ensure that contact between the workpiece and the platform will be close in contact. And also there are some contaminations present in the seeds, so selected seeds that also burn out through the heat roller. Right now, this is what we make sure that raw product should be free from the contaminations. Right. So once we done this process, we make ensure this, then we can take the laser. Now I will tell you that laser. Now our workpiece is ready for performing or ready for creating the 3D object. Now we need to expose this raw material to the laser. Now the laser beam is scan this. There will be the arrangements of the mirrors and all these things. The laser beam is traces the raw material. Once it traces the raw material, again it is fuse the materials, and also what kind of the structures we need. When we can make even we need to a hole here, and we need to some different structure in the seats. That portion only to traces and cut by the lasers. Hence we create the required shape and size over the seat. Right, this is what so exposed part only we want this much, and also we need some designs over the seat that is made by the laser beam. Right, that gap is filled by the raw material later. So here once we can take all the arrangements are done, then you can take the start button. See, right, see, assume it is a once the layer will come this side, and so it move forward and then it moves backward, means what it means, it means that new layer will be come upon the platform. The roller will be roll the thin sheets. You know the function of the rolling. One, the contaminations present in the raw material are burn out, and also there will be the stretching mechanism or stretching purpose. We need to make sure that this thin layer should be contact with the platform, or first next layer will be should be contact with the first layer. Right, now initially there will be the platform. Whenever we are creating the first layer is closely contact with the platform, right, with the action of the roller. And the second raw material will come here, the thin layer will come when now the roller is roll over the thin sheet. Now the thin sheet is contact with the first layer, that close contact between the first layer and second layer. Again this portion is exposed to the scanning. The scanner is traces the required shape and size, traces the material and that generate the required shape and size. Again the second layer will be created. Now the platform is moves down. Again raw material will continue to supply. Again roller will be roll over the third layer. Then the third layer is close contact with the second layer. Then that exposed to the laser. Again the laser is traces and creating something over the third layer. Once that work is done, again the platform is moves down. Now that there are 3 layers are generated. The same way the 4th layer will come, 5th layer will come, 6th layer will come. This will keep on going till the required shape and size and required length of the product to be generated. Till that we keep on continuing the process, keep on supplying the raw material to the platform, and this roller will be keep on continuing to roll over the thin sheets. Then the thin sheet exposed to the scanning, hence it also contact with the bottom layers. So now the layer by layer, now we can able to see this is the 3D generated 3D product. How it generated? The layer by layer. So first layer is over the part 1, second layer is over the first layer, third layer is over the second layer, and fourth layer is over the third layer, and fifth layer is over the fourth layer. The same way the 3D product will be generated. Once we got the required shape and required height of the 3D product, required shape and size of the 3D product, hence we can stop the process. Then we can collect this layered part or else 3D part. Then the 3D part is for the required process. Then that we need to send for the required process. If it requires, then we can send for the further process. If it does not, then we can keep it into the room temperature. Hope you understand. Hello? Is it clear? Are you there? I'm audible?
Yes,
Clear
sir.
or not? Clear now?
Clear.
Yes. Now, but instead of using the powder materials of metallic and non-metallic, directly we are using, this is only the thing it change here is, suppose you are comparing this LOM process to the previous one. Previous one, what we did, we are supplying the powder materials from the bed. Here we have this side, there will be the bed. In that bed is completely filled by the raw materials which are in the form of the powders. Instead of the powders, here we are using the thin sheets. Once we thin sheets, here we are supplying the thin sheets. That's it only. Hence this process becomes the laminated object, because the sheets are laminated, one layer and second layer, third layer. This process we can call it as a laminating process. Thin sheet is combined together, one sheet over the other sheet. So like the way we are creating the 3D product, hence this combination of the different layer structure parts, this is look like a lamination portion. Hence we are giving the name laminated object manufacturing. I hope you understand this. Just we will take the pre-test, just a minute, 2 minutes, we will finish up this. Okay, the simulation of laminated object manufacturing process. Here we have some questions about this process. LOM is an example of which of the following techniques: material jetting, material sheet lamination, material extrusion, and laser sintering. Which of the answer is suitable for the following answer is suitable for the these techniques? Come on, quickly. So we will wind up in another 2 minutes. We will wind up this class. Come on. LOM is an example of which of the following is techniques? LOM is material jetting, material sheet laminations, material extrusion, or laser sintering.
D, sir.
D is a laser sintering. Laser sintering is already over. This is the laminated object. Here we are taking the thin sheets. Thin sheets are laminated here.
B, sir.
B is the answer here. The material is in the form of, yes, material which is in the form of thin sheets. That once this becomes a laminated process. Second one, in LOM process, sheets are cut using the laser according to the information stored, right? Dark file, SVG file, STL file, or all of the above. I told you that the laser will scan the thin sheets and that will cut the required shape and size. Hence that part will be built, right? Which file we can able to store these informations? STL file or SVG file or doc file? Standard triangular language file.
STL, sir. STL file.
STL files. In LOM process, the adhesive coated sheets are glued by the application of heat, pressure, chemical reaction, both A and B. Think and answer. LOM process is adhesive coating sheets are glued by the applications of heat, pressure, chemical reaction. Huh.
C, sir. Chemical reaction.
No, here we will not take any chemical reactions with
Both A and B, sir.
Yes, exactly. So both A and B. Which of the because I will clear heat. So that roller will roll over the thin sheet now. So roll over thin sheet means that will apply the both pressure and heat. So which of the following is limitations of the LOM process? Surface finish and accuracy, no external support material, no chemical reactions, all of the above. Which of the following is a limitation? Which one? Let's guess the answer if you don't know exactly. Okay.
All of the above.
All of the above.
All of the above.
All of the above. All of the above are the limitations. See, now I will take first one. Let's see what happens. The fifth one. Which of the following adhesive coating materials can be used for the LOM process? Papers, plastics, metal laminates, all of the above. Which of the following adhesive coating materials can be used for the LOM process? Can you take the papers? Can you take the plastics? Or can you take the metallic laminates? All of the above you can take. You can able to take all of the above?
Yes, sir, all of them.
Yes, all of the above. Submit the quiz.
Yes, sir. D, sir.
Yes, 100% right. So now we scored 5 out of 5. All answers are correct. Yes, all answers are correct. Now our score is 5 out of 5. Okay. Now I will take the attendance. Now we'll wind up because however the time is up. Just give me a minute. I will take the attendance. Right. Okay. Now you can leave the meeting.
Sir, second day.
Thank you, sir.
Welcome. Second I. Okay.